For decades, the narrative of higher education in Zimbabwe was bound to an outdated blueprint. Education 3.0 focused purely on teaching, research, and community service. It produced brilliant minds, but brilliant minds that exited the gates of academia, holding certificates, searching for jobs that didn't exist. But the Second Republic rewrote the script, anchored by the macroeconomic vision to achieve an upper-middle income society by 2030. The government launched the National Development Strategy 1. Under its key pillar of human capital development and innovation, a new directive emerged: Heritage-Based Education 5.0. Two explosive pillars were added to academia: innovation and industrialization. This is the untold story of how Zimbabwe's universities stopped just printing diplomas and became the engine room for national self-reliance. We begin at the capital's premier institution, the University of Zimbabwe. Under NDS-1's thrust to move the economy up value chains and substitute imports, the university addressed a critical national vulnerability. For years, every vehicle on Zimbabwean roads bore a hidden economic scar. The country imported 100% of its vehicle registration plates, bleeding millions in foreign currency annually. Today, through National Transtech, University of Zimbabwe has completely localized the production of smart, reflective vehicle registration plates. By capturing the value chain domestically, this facility has plugged the forex leak, proving that import substitution isn't just a policy on paper, it's active on our highways.
National Transtech Solutions is the number plate production plant in Zimbabwe, which was commissioned in December 2022 by His Excellency Comrade Emmerson Mnangagwa, in line with Vision 2030 to fulfill the NDS-1 resolutions. The project was born of a consortium of 8 higher tertiary institutions through the heritage-based Education 5.0 industrialization model, which continues to bring solutions to challenges that our country is facing. As you all know that Zimbabwe was facing challenges in access of number plates. The commodity was once imported, and this project resolved by cutting the importation bill. The number plates are now being locally produced at a cheaper price and easily accessible to all citizens. The plant has a capacity to produce about 14,000 number plates per day, which is enough to meet our market demand in Zimbabwe, thereby resolving the problem of access of number plates and reducing and making them easily accessible to all citizens. The machinery is in line with the fourth industrial generation of equipment. The number plate set is complemented by a secure plate number plate, which bears the serial numbers of the number plates associated with the registration number. We would like to thank the government under the leadership of His Excellency Comrade Emmerson Mnangagwa for supporting projects that continue to solve problems for our nation.
Further north, Bindura University of Science Education has shattered the myth that rural-located universities cannot drive cutting-edge, diverse industrialization. Aligning perfectly with NDS, one's priority of devolution and decentralization, Bindura University of Science Education has created a multifaceted manufacturing ecosystem rooted directly in local heritage and science. First, look into their biochemistry labs. Rejecting chemical-heavy imports, Bindura University of Science Education scientists turned to indigenous flora. The result? The Prodent Herbal Mouthwash Plant, a state-of-the-art commercial facility producing medical-grade oral hygiene solutions using locally harvested, natural antimicrobial plants. Next door, a regional breakthrough.
So this whole plant is a mouthwash, herbal mouthwash production plant. We call the herbal mouthwash Prodent. So this is an antiseptic herbal mouthwash that we produce using natural products. These are the indigenous herbs that we find here in Zimbabwe. So in this plant, we have our mixing station, we have our filling station, and we also have our sealing station, and then we do have our packaging and dispatch station. So to start off with our mixing station, that is where we input all the ingredients, all our concentrate, our active ingredients and excipients, and then we mix them using our automatic mixer. And then it also has a filtering system where it does all the automatic filtration to remove all impurities, to remove sediments, and to remove microbial contamination using also UV light. And then after the filtration, our product goes into our first storage tank. This is where we regulate the pressure that then pushes our product into our second storage tank, which then leads to the filling machine. So after our product has stayed in the first storage tank, we activate it to move on to the second storage tank. Here we are also regulating the pressure that we need to fill our bottles with. So from the second storage tank, our product moves over to the filling machine where bottles are lined up manually, but then they are automatically filled using controlled air pressure. So this process, it takes a few seconds and it fills 4 bottles at a time. And the reason why we take a few seconds is because we want to minimize contamination. Our product does not have to pass through too much air, which then introduces contamination, bacteria, fungi, viruses into our product. We want to maintain sterility of the herbal mouthwash. And then after our filling is done, our product automatically moves from the first station of the filling up to our sealing. So with the sealing, we have a capping machine which automatically feeds our caps onto the bottles that have been filled. And then we also have an automatic screw cap sealer. So the seals or the caps, they are screwed onto the bottles, and then our product would automatically come out of the sealing machine. And then we also do quality checks at each stage of this process. And when the bottles are not properly filled or they are not properly capped, we then take them to the side and discard them and sort everything out before we do our labeling. And then after labeling, they are safe for storage and for safekeeping.
Bindura University of Science Education Optech lens production plant stands as a magnificent first for a university setup in Southern Africa. Harnessing the expertise of the university's optometry department, this plant mass manufactures high-precision, custom prescription glass and optical lenses, rendering expensive imported eyewear a thing of the past.
Okay, so when a patient comes in, we first start by checking how well they see using our Snellen charts. So that's the chart. It checks how well a person can see, starting from the biggest letters right down to the smallest letters that we have. When we're done checking a patient's sight, we also check on the integrity of the eye. We check using what we call an ophthalmoscope. So this is an ophthalmoscope. It checks on the integrity of the parts of the eye. When we are done with the ophthalmoscope, we can also use the slit lamp, which is right here. It also looks into your eye right up to the back of your eye where the optic nerve is. So if it's a patient who requires spectacles, after checking their vision, we then bring them to the autorefractor. The autorefractor gives us an objective idea of what your refractive error is, which is basically the kind of lens that you may need. So when we get that objective idea of the kind of lenses that you may need, we then move to the phoropter. So the phoropter then gives us the subjective prescription that you require. So you're changing different lenses based on what the patient says they can see or they can't see. So the phoropter then gives us the final prescription of the patient. So when the patient is done in the consultation room, they then go to the dispensing room.
Bindura University of Science Education didn't stop at healthcare. In the tech sector, they launched Palpo Technologies. Far from a simple repair shop, this industrial unit actively assembles and manufactures robust ICT hardware, laptops, tablets, and smartphones, driving NDS1's goal of achieving a truly digital economy.
Good day, welcome to Palpo Technologies, where we assemble electronic devices starting from smart features, feature phones, up to smartphones, laptops, and then tablets. So today we're working on smart tablets, where we'll be reworking on them to ensure that the product is of desired quality and up to customer standards. So at the moment we are working on the ST100, where we'll start by opening up the tablet, then disconnecting the battery. After disconnecting the battery, dismount the chip on the phone. And then after dismounting the chip on the phone, there will be disconnection of the antennas and touch screen. And then after that, there will be bolstering of the charging port to ensure that the charging port doesn't get uprooted when we're charging devices. And then after that, here we'll check if everything is connected properly. And then we'll start reassembling of the device. We'll start by bolting on the motherboard to the frame of the phone. Thereafter, we'll be connecting our antennas and touch screen. And then thereafter, we'll now be connecting the battery. After connection of the battery, we'll switch on the smart tablet to see if everything is working. Then after switching on the smart tablet, there will now be thorough testing of each and every functionality of the tablet to ensure that it is working up to expected standards. And then all the tablets that are not working to expected standards are taken over to the repair station, where they are now repaired thoroughly, component by component, ensuring each and every component is working up to expected functionality. So this is the process of the smart tablets. Now they are functioning properly. Then prior your arrival, we were assembling smartphones. Now we were at the software installation stage. Now, after software and IMEI installation on this workstation, where he assigns a specific serial number for the device, an IMEI, which is an international recognized number, which is unique to each and every device, we then update the software, install the software, make sure that it's up to date. After that, it's now ready for packaging, where we will now be ensuring that the device is clean and there's no scratches on it. And then there's polishing of the device. And then there'll be assembling of the packaging components, which include your chargers, your cable, your SIM ejectors, Thereafter, the phone is put into a plastic to ensure that it's delivered in the right state as you'd expect it to be in as a customer. To ensure that every component has been assembled into the packaging, we scale and we have a range that we expect the device to be in. So the scaling, which is the final stage before capturing of the device details into our traceability system. Then once the device assembling and packaging is complete, we capture the device details and the date of manufacture for our traceability and to know that when the device was assembled. And it's a report that also updates us on whatever challenges the device might have had during the assembly line. After capturing of the device details, we now go to our shrink wrap station where we now seal the devices for delivery to the customer.
As NDS-1 drives economic development directly into marginalized districts, the true definition of rural industrialization comes alive in Mutoko. Operated by Finealt Engineering, an industrial vehicle born straight from university and polytechnic research, the Mutoko Bioeconomy Industrial Park is a masterclass in the circular economy.
This is Mutoko, and this is where Education 5.0 comes to life. At the Fine Alt Processing Plant, we don't just produce cooking oil, we produce opportunity. It starts with our farmers, delivering sunflower and soya to a plant that doubles as a classroom. Through partnerships with local colleges and universities, students get hands-on training in food processing, quality control, and agro-industrial engineering. Here, research meets reality. Innovation isn't just theory, it's new ways to extract more oil, reduce waste, and add value to what Zimbabwe grows. Because when production happens here, skills stay here. Every bottle of fine alt oil supports the fifth pillar, industrialization. When we process locally, we create jobs, keep graduates in Mutoko, and prove that Zimbabwe can feed and build itself. Fine Alt Processing Plant, turning harvests into products, students into experts, and Education 5.0 into action. Proudly made in Mutoko, powering Zimbabwe. Education 5.0 is more than a policy. It's Zimbabwe building Zimbabwe. It's teaching, research, and community service. But it doesn't stop there. The fourth pillar is innovation. The fifth is industrialization. This is what it looks like. At the National Biotechnology Authority, our universities and industry partners are producing CoughSol, a homegrown solution, researched here, manufactured here, solving problems here. At Verify Engineering, the same model applies to medical gas. Students and engineers work side by side to produce, test, and supply the oxygen and medical air that keeps our hospitals running. No waiting for imports, no outsourcing expertise. Because when production happens here, education happens here. Labs become factories, theses become products, graduates become employers. This is Education 5.0, turning knowledge into goods, learners into builders, and Zimbabwe into its own supplier. Innovate, industrialize Zimbabwe.
Meanwhile, in Gweru, Midlands State University answered NDS-1's urgent call for enhanced national health and well-being. Historically, complex medical biopsies, advanced cancer screens, and DNA tests had to be flown out to South Africa or Europe. Opened as a crown jewel of the framework, Midlands State University National Pathology Research and Diagnostic Center is now one of the most advanced medical testing facilities in sub-Saharan Africa. It handles complex molecular diagnostics, bone marrow analysis, and toxicology locally, providing rapid, affordable testing for everyday citizens, while anchoring the Midlands State University Industrial Park, which manufactures everything from pharmaceuticals to textile protection gear.
This is MSU Enterprises, the Innovation and Industrialization arm of the Midland State University. Here we have got 4 units, namely the Food and Beverages unit, where we make fruit juices and water. For our fruit juices, we mainly focus on doing value addition for all the fruits that we're actually canvassing from our locals. We buy from Lower Gweru, our lemons and our mangoes there. And the second unit that we house here is the clothing unit. Under the clothing unit, we've got 2 divisions. One division makes garments, any garment of your choice that you can think of. From workwear, industrial wear, our PPE, we can make everything. And we are already making garments for the Parengatua Hospital. We won the tender last year. The second unit under the clothing manufacturing unit is the Butter ABU project, where we are actually in partnership with Butter. We are making their upper tops for their bumpers and their tummy. And they will take the upper tops, they'll put the sole, and you find them in the Butter supermarkets. The third unit that we house here at MSU Enterprises is the chemical manufacturing unit. Under the chemical manufacturing unit, we have a wide range of products from detergents to household cleaning detergents. And our new baby that we house there is the degreaser, the popular degreaser, which is being loved by the mines. We are actually selling it to Unki Mine at the moment. The last unit that is not housed here is the press and publications unit. Under the press and publication unit, we work with printing and publishing of any printing material that you can think of, any books, anything that you can think of that needs printing, we can actually do. We have large formatting printing, we can do billboard printing. So any printing that you can think of at your workplace, we are here to serve you. So yes, this is MSU Enterprising, where we are creating an ecosystem within the academic sector. We learn, we innovate, and we industrialize. Thank you so much.
As the page turns to the final phase of Vision 2030, the Second Republic has launched the National Development Strategy 2, where NDS-1 successfully built the infrastructure and established 13 breakthrough university industrial hubs. NDS-2 is designed to consolidate these gains. The scripts of old told a story of dependency. The modern reality of NDS-1 and NDS-2 is a narrative of triumph, self-reliance, and sheer intellectual audacity. From number plates to optical lenses, from indigenous fruits to world-class diagnostics, Zimbabwe's universities have stepped out of the classroom and are manufacturing the future. None of these groundbreaking transformations would have left the drawing board without the unwavering commitment, strategic foresight, and radical financial backing of the Second Republic. We extend a monumental thank you to the government of Zimbabwe under the visionary leadership of His Excellency President Dr. Emmerson Dambudzo Mnangagwa. By introducing heritage-based education 5.0 and boldly anchoring it within the NDS-1 and NDS-2 national policies, the government did not just reform a curriculum, it unlocked the sovereign potential of an entire nation. Through direct treasury funding, the construction of world-class infrastructure, and an unshakable belief in local intellectual capacity, the Second Republic has permanently shattered the chains of import dependency. Thank you for empowering our youth, protecting our heritage, and charting an unstoppable path toward a prosperous, highly industrial, upper-middle income society by 2030. The future is no longer bought. Thanks to our government's vision, the future is proudly made in Zimbabwe.